Hello and welcome to the Dreamy Physicist. I'm so glad you're here. Whether you're settling in for the night, curling up somewhere comfortable, or just looking for a gentle journey through the cosmos, you've come to exactly the right place. This is your quiet corner of the internet where science gets soft spoken and curiosity puts king on a peaceful on its pajamas. Tonight, we're embark voyage to the outer edges of our solar system to explore something truly extraordinary, a visitor from the depths of interstellar space that has astronomers whispering questions they never thought they'd need to ask. Now, I do hope this exploration isn't so fascinating that it keeps you awake, but if it does, at least you'll be learning about one of the most intriguing mysteries in modern astronomy. A fair trade, I'd say, before we drift into the depths of space together. If you enjoy these gentle cosmic journeys, I'd be ever so grateful if you tapped the like button, subscribed, or simply left a comment telling me where in the world you're watching from and what draws you to the stars. All right, take a deep breath, settle in, and let's begin our quiet expedition into the mystery of 3A Atlas and the profound questions it raises about life beyond our pale blue dot. Imagine, if you will, a cosmic messenger traveling through the darkness of space for millions, perhaps billions of years, carrying with it secrets from a distant star system. It journeys alone through the void until one day it enters our solar system, moving unlike anything we've ever seen before. This isn't science fiction. This is the remarkable true story of 3 Atlas, an object so unusual, so defiant of our expectations that it's forcing scientists to reconsider some of our most fundamental assumptions about what might be possible in the universe. 3. I Atlas first caught our attention in August of 2021 when astronomers using the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey, spotted what they initially thought was just another comet. But as they watched this mysterious visitor more closely, something didn't quite add up. It was moving in a way that seemed to defy the basic laws of physics, or at least our understanding of how objects should behave when they venture close to our sun. You see, when most comets approach the sun, they follow a predictable pattern. They speed up as they get closer, pulled by our star's immense gravity. They brighten as the sun's heat vaporizes ice on their surface, creating those magnificent glowing tails we've all admired, and then they slow down as they swing around and head back out into the cold depths of space. It's a cosmic dance that's been choreographed by gravity and physics for billions of years. But 3I Atlas was writing its own choreography. This enigmatic visitor was accelerating in ways that couldn't be explained by the sun's gravity alone. It was as if some invisible force was giving it an extra push, a gentle nudge that sent it speeding through our solar system faster than it should have been going, and this gentle acceleration continued even as it moved away from the sun, defying everything we thought we knew about how objects behave in space. Now you might think, well, perhaps it's just an unusual comet. Maybe there's ice vaporizing from its surface, creating a kind of natural rocket effect, pushing it along, and that would be a perfectly reasonable explanation. Except for one small problem, 3I Atlas showed no signs of the typical comet activity. No bright coma of gas and dust, no magnificent tail streaming behind it as it raced through space. It appeared for all intents and purposes to be completely inert, a dark, silent traveler that somehow managed to accelerate without any visible means of propulsion. This is where our story begins to venture into truly extraordinary territory. Because when scientists attempted to explain this mysterious acceleration, they found themselves considering possibilities that would have seemed like pure fantasy. Just a few decades ago, some suggested it might be outgassing from previously unknown volatile materials. Others proposed exotic ice compositions that could sublimate without creating visible emissions. But as each conventional explanation was examined and found wanting, researchers began to whisper about more unusual possibilities. The scientific community found itself divided into camps, some maintaining that there must be a natural explanation we haven't discovered yet, others beginning to wonder if 3-Eye Atlas might represent something unprecedented in our experience of the cosmos, and a small but growing group of scientists started asking a question that sends shivers down the spine of anyone who has ever looked up at the night sky and wondered if we're alone. Could 3-Eye Atlas be artificial? Could this mysterious visitor, racing through our solar system with its inexplicable acceleration and lack of visible comet activity, actually be technology from another world? Now, before you dismiss this as the stuff of science fiction, let me take you on a gentle journey through the evidence and the reasoning that has led some of the world's most respected astronomers to seriously consider this extraordinary possibility, because the story of 3-Eye Atlas is not just about one unusual object. It's about how science works, how we test our assumptions, and what happens when the universe presents us with something that doesn't fit neatly into our existing categories. To understand why 3-Eye Atlas is so puzzling, we need to first appreciate what makes objects in space behave the way they do when a comet approaches the sun. It's subjected to intense heat that vaporizes ice and other volatile materials on its surface. These materials stream away from the comet, creating not just the beautiful tail we can see, but also a kind of natural propulsion system. The escaping gas pushes against the comet, like air rushing out of a balloon, causing it to accelerate in ways that pure gravity alone cannot explain. This phenomenon, called outgassing, is well understood and entirely predictable. Astronomers can calculate how much a comet should accelerate based on how much material it's losing. And sure enough, when they observe typical comets, the math works out beautifully. The observed acceleration matches the predicted acceleration based on the visible outgassing. It's one of those elegant examples of physics working exactly as our theories suggest it should. But 3-Eye Atlas broke this elegant relationship. It accelerated more than gravity alone could account for, yet it showed no signs of the outgassing that should have been responsible for that extra push. It was like watching a balloon accelerate through the air without any visible gas escaping from it. The effect without the cause, the acceleration without the explanation. As astronomers around the world trained their telescopes on this puzzling visitor, they began to realize they were looking at something unprecedented in our solar system's recorded history. Here was an object that seemed to be propelling itself through space by unknown means, an interstellar traveler that had journeyed from the depths of space to challenge our understanding of what's possible. The implications were staggering. If 3-Eye Atlas truly was accelerating without visible outgassing, then either our understanding of physics was incomplete, or we were looking at something that operated by principles we didn't yet understand And in the quiet moments between observations, when scientists sat alone with their data, some began to consider a possibility that would have been unthinkable just a generation ago. What if 3I Atlas wasn't natural at all? What if this mysterious visitor, with its impossible acceleration and lack of conventional comet behavior, was actually a piece of technology, a probe or perhaps even debris from a civilization among the stars? Now I want to be clear that this isn't the plot of a Hollywood movie or the fevered imagination of science fiction writers. This is a genuine scientific hypothesis being seriously considered by respected researchers at major universities and observatories around the world, because sometimes the universe presents us with phenomena so unusual, so unexpected, that we have no choice but to consider extraordinary explanations. The idea that 3I Atlas might be of artificial origin isn't based on wishful thinking or a desire to find aliens. It's based on the simple fact that conventional explanations seem inadequate to account for its observed behavior when natural processes fail to explain what we're seeing. Science demands that we consider alternative possibilities, no matter how unusual they might seem. And this is where our gentle journey through the cosmos takes on a deeper significance. Because 3I Atlas isn't just challenging our understanding of comets and asteroids, it's forcing us to confront one of the most profound questions in all of science. Are we alone in the universe? And if we're not, how would we recognize evidence of other civilizations when it appears in our solar system? The story of 3I Atlas is still being written. As I speak, astronomers continue to analyze data from this mysterious visitor, searching for clues that might definitively explain its unusual behavior. But regardless of what they ultimately discover, this enigmatic object has already accomplished something remarkable. It has reminded more wonderful than we often does that the universe is far stranger. And remember, as we continue our exploration of this cosmic mystery, we'll delve deeper into the evidence both for and against the artificial hypothesis. We'll examine what other scientists have proposed, and we'll consider what it might mean for humanity. If 3I Atlas truly represents our first confirmed contact with technology from another world. But for now, as we drift through the darkness of space alongside this mysterious visitor, let yourself wonder about the possibilities. Imagine what it might mean to live in a universe where we are not alone, where other minds have looked up at their own night skies and wondered about the cosmos, and perhaps even sent their own messengers to explore the vast reaches of space. 3I Atlas continues its journey through our solar system, carrying with it questions that may reshape our understanding of our place in the cosmos. And as we follow its path through the darkness, we're reminded that sometimes the most profound discoveries come not from finding what we expect, but from encountering what we never imagined possible. The mystery deepens when we consider that 3I Atlas isn't the first interstellar visitor to grace our solar system with its presence. Just a few years earlier, in 2017, astronomers discovered another enigmatic traveler called Oumuamua, and the parallels between these two cosmic wanderers are both fascinating and deeply unsettling for those trying to understand what we might be witnessing. Oumuamua, like 3I Atlas, exhibited that same puzzling, non gravitational acceleration as it swept through our solar system. It too seemed to be pushed by some invisible force, speeding up in ways that couldn't be explained by the sun's gravity alone. And just like our current mystery, Oumuamua showed no signs of the typical comet activity that might account for this extra acceleration. No glowing coma, no streaming tail, no visible outgassing whatsoever. The scientific community was already grappling with the implications of Oumuamua when 3I Atlas arrived, and suddenly we found ourselves facing not one, but two interstellar objects behaving in ways that challenged our fundamental understanding of how things should work in space. It's as if the universe decided to present us with a pattern, a recurring theme that whispers of possibilities we're only just beginning to contemplate. Dr. Avi Loeb, the former chair of Harvard's astronomy department, was among the first to publicly suggest that Oumuamua might be artificial in origin. His reasoning was elegantly simple. When natural explanations fail to account for observed phenomena, science demands that we consider alternative hypotheses, no matter how extraordinary they might seem. The same logic that led him to propose that Oumuamua could be a light sail from another civilization now applies with even greater force to 3I's Atlas. But what exactly would an artificial interstellar object look like? How would we recognize technology from another world if it came drifting through our solar system? These questions have kept astronomers awake at night, not with worry, but with wonder at the possibilities that might be unfolding before our very eyes. One intriguing hypothesis suggests that 3I Atlas could be what scientists call a probe, a piece of technology designed to explore and possibly study other star systems. Imagine, if you will, a civilization that achieved spaceflight millions of years before humans even evolved on Earth. They might have sent countless robotic explorers into the galaxy, each one programmed to visit star systems and gather information about planets, asteroids, and perhaps even signs of life. Such a probe wouldn't need to be large or obviously artificial. In fact, it might be designed to appear as natural as possible, blending in with the countless rocks and ice balls that drift through space. Its propulsion system might be so subtle, so elegant, that it would appear to outside observers as nothing more than a gentle, inexplicable acceleration, a whisper of technology masquerading as a mystery of physics. The propulsion mechanism itself presents fascinating possibilities. Advanced civilizations might have developed technologies we can barely imagine, perhaps using the pressure of starlight itself, or exotic matter we haven't yet discovered, or even principles of physics that remain unknown to us. The acceleration observed in 3I Atlas is remarkably gentle, almost organic in its subtlety, as if whatever is driving it was designed to avoid detection or perhaps to minimize stress on the object's structure during its long interstellar journey. Another compelling possibility is that 3I Atlas represents what researchers call technological debris, the remnants of some ancient civilization's spacefaring activities. Just as our own solar system is littered with defunct satellites and spent rocket stages, perhaps the galaxy is filled with the technological detritus of civilizations that rose and fell eons ago, a fragment of an alien spacecraft, still following its programmed trajectory millions of years after its creators vanished into cosmic history. This idea carries that we might be witnessing the ghost with it a profound melancholy, the notion of a civilization that once looked up at their own night sky with the same wonder and curiosity that drives us today. Their technology continues its silent journey through space, a monument to dreams and ambitions that may have ended long before our own sun finished forming from its primordial cloud of gas and dust. The implications of either scenario, active probe or ancient debris, are staggering for our understanding of life in the universe. If 3I Atlas is indeed artificial, it would represent the first confirmed evidence that we are not alone, that somewhere among the stars, other minds have gazed into the cosmos and reached out to touch it with their technology. But perhaps even more intriguing is what the existence of such objects might tell us about the prevalence of life and intelligence in our galaxy. If we can detect two potentially artificial interstellar visitors in just a few years of modern observations, it suggests that such objects might be relatively common. The galaxy could be teeming with the technological signatures of civilizations both ancient and contemporary, a vast network of exploration and communication that we're only now beginning to glimpse. The timing of these discoveries is particularly remarkable. We've only had the technology to detect and study interstellar objects for a few decades, and already we've encountered two that defy conventional explanation. It's as if the universe has been waiting for us to develop the right instruments, the right theoretical frameworks, before revealing these cosmic puzzles to our searching telescopes. Some researchers have proposed that advanced civilizations might deliberately send probes to star systems that show signs of developing intelligence. Perhaps there are automated sentinels scattered throughout the galaxy, programmed to activate or change their behavior when they detect the radio signatures of emerging technological civilizations. Could 3IA Atlas be responding to our own electromagnetic chatter, the growing bubble of radio and television signals that has been expanding outward from Earth for the past century? The object's trajectory through our solar system is itself a source of fascination and speculation. Unlike a random chunk of interstellar debris, 3I Atlas followed a path that brought it relatively close to several planets, offering any hypothetical sensors aboard the object excellent opportunities to study our solar system's architecture and composition. If it is indeed a probe, it chose or was programmed to choose a trajectory that maximized its scientific return. The gentle nature of its acceleration also suggests a level of technological sophistication that we can barely comprehend. Rather than the crude chemical rockets or even the ion drives we use for our own space exploration, whatever is propelling 3I's Atlas operates with such subtlety that it took our most sensitive instruments to detect it at all. This speaks to a mastery of physics and engineering that would make our current space technology look like stone tools by comparison. Yet, for all the excitement and speculation surrounding 3II Atlas, we must remember that science demands extraordinary evidence for extraordinary claims. The artificial hypothesis, compelling though it may be, remains just that, a hypothesis. There are still natural explanations being explored, exotic forms of outgassing that might not produce visible emissions, unusual compositions that could account for the observed acceleration, or perhaps entirely new physical processes that we haven't yet discovered or understood. The beauty of this mystery lies not in rushing toward conclusions, but in the careful, methodical process of elimination that characterizes good science. Each natural explanation that fails to account for the observations brings us one step closer to either discovering new physics or accepting that we may indeed be looking at technology from another world. As Three Eyes Atlas continues its journey away from our sun, growing fainter and more distant with each passing day, astronomers around the world continue their analysis of the precious data collected during its brief visit. Spectroscopic measurements that might reveal its composition, precise tracking of its trajectory that could yield clues about its origin, and continued monitoring for any signs of activity or change in behavior. The object has now passed beyond the orbit of Jupiter, heading back into the cold darkness of interstellar space, carrying with it the secrets of its true nature. Whether it's an exotic piece of natural debris or humanity's first confirmed encounter with alien technology, Three Eye Atlas has already changed how we think about our place in the cosmos and what we might expect to find as we continue our exploration of the universe around us. The profound implications of Three Eye Atlas extend far beyond the realm of academic astronomy. If we are indeed witnessing evidence of alien technology, it would fundamentally alter humanity's understanding of our cosmic significance. We would no longer be able to think of ourselves as potentially unique or alone in the vast expanse of space. Instead, we would become members of a galactic community that we're only just beginning to glimpse. Consider for a moment what this might mean for our species. Throughout human history, we have gradually expanded our understanding of our place in the universe. We learned that Earth is not the center of the solar system, that our sun is just one of billions of stars, and that our galaxy is merely one among countless others. Each revelation has been both humbling and awe-inspiring, forcing us to reconsider our assumptions about the nature of existence itself. The discovery of artificial interstellar objects would represent perhaps the most significant of these revelations. It would suggest that the universe is not only vast and ancient, but also populated by intelligences capable of engineering marvels we can barely comprehend. The technology required to send even a simple probe on an interstellar journey represents achievements in physics, engineering, and long term planning that dwarf our current capabilities. Yet there's something almost poetic about the way Three Eye Atlas has chosen to reveal itself to us. Rather than arriving with fanfare or obvious artificial signatures, it whispers its secrets through subtle accelerations and gentle mysteries. It invites us to question, to investigate, to grow in our understanding. Perhaps this is how first contact was always meant to happen, not through dramatic landings or bold announcements, but through quiet puzzles that challenge us to expand our scientific horizons. The object's behavior raises fascinating questions about the intentions behind its creation. If Three Eye Atlas is indeed a probe, what was it designed to accomplish? Was it sent to study developing civilizations like our own, or is it part of some vast galactic survey mapping the distribution of planets and resources throughout the Milky Way? Perhaps it represents something even more ambitious, a component of an ancient communication network linking civilizations across interstellar distances. Some researchers have speculated that advanced civilizations might use interstellar objects like Three Eyes Atlas as beacons or signposts, markers that indicate the presence of intelligence to other spacefaring species. The unusual acceleration could be a deliberate signature, a way of saying, this object is not natural, pay attention to it. In this interpretation, we are witnessing a kind of cosmic archaeology, uncovering artifacts left by civilizations that may have thrived when our solar system was still young. The engineering challenges involved in creating such an object boggle the mind. To survive the harsh environment of interstellar space for potentially millions of years requires materials and design principles far beyond our current understanding. The probe would need to withstand cosmic radiation, micrometeorite impacts, and the extreme cold of deep space while maintaining enough functionality to carry out its mission. The fact that 3i Atlas appears to still be operational after its long journey speaks to a level of technological mastery that we can only dream of achieving. But perhaps the most intriguing aspect of this mystery is what it might tell us about the nature of intelligence itself in the universe. If civilizations regularly send probes to explore other star systems, it suggests that curiosity and the drive to explore are not unique to humans. Somewhere among the stars, other minds have wondered about distant worlds and taken concrete steps to satisfy that wonder. This universality of curiosity could represent one of the most profound connections between humanity and any potential alien civilizations. Despite the vast differences in biology, environment, and evolutionary history that would separate us from our cosmic neighbors, we might share this fundamental drive to understand and explore the universe around us. The probe that is 3i Atlas, if that's what it is, would represent a bridge between minds separated by light years and perhaps millions of years. The scientific community's response to 3i Atlas has been fascinatingly varied. While some researchers embrace the possibility of artificial origin, others remain cautiously skeptical, preferring to exhaust all natural explanations before considering more exotic possibilities. This tension is healthy and necessary for good science. It ensures that extraordinary claims are subjected to extraordinary scrutiny while preventing premature dismissal of genuinely revolutionary discoveries. The debate surrounding 3i Atlas has also highlighted how unprepared we might be for confirmed contact with alien technology. Our protocols and procedures for such encounters are largely theoretical, developed by committees and think tanks, but never tested against real world scenarios. The subtle nature of 3i Atlas's artificial signatures, if they are indeed artificial, suggests that future encounters might be similarly ambiguous, requiring new frameworks for evaluation and response. Meanwhile, the object itself continues its silent journey through our solar system, indifferent to the debates and speculation it has inspired. Its trajectory will eventually carry it beyond the influence of our sun's gravity back into the interstellar medium from which it emerged. Unless we take action to study it more closely while it remains within reach of our instruments, 3i Atlas may disappear into the cosmic dark, leaving us with nothing but memories and unanswered questions. This urgency has prompted some scientists to propose ambitious missions to intercept and study the object directly. Such missions would represent significant technological and financial challenges, requiring spacecraft capable of matching 3i Atlas's trajectory and speed while carrying sophisticated instruments for close-up analysis. The window of opportunity is narrow and closing rapidly as the object moves farther from the sun and becomes increasingly difficult to reach. The data we have already collected from 3i Atlas will likely be analyzed and reanalyzed for years to come. Every spectroscopic measurement, every observation of its motion and behavior, every photograph taken by ground based and space based telescopes represents a piece of a cosmic puzzle that may ultimately reshape our understanding of life in the universe. As we continue to monitor 3i Atlas's departure from our solar system, we're reminded that we live in an age of unprecedented discovery. Our instruments have become sensitive enough to detect the subtle signatures of potentially artificial objects. Our theoretical frameworks sophisticated enough to recognize when something doesn't fit our models, and our scientific community mature enough to seriously consider possibilities that previous generations might have dismissed as fantasy. The story of 3i Atlas is far from over. Whether it ultimately proves to be an exotic natural phenomenon or humanity's first confirmed encounter with alien technology, it has already succeeded in expanding our sense of what might be possible in the universe. It has reminded us that we are still explorers in a cosmos full of surprises, still students in a universe that has much left to teach us. In the quiet hours when astronomers point their telescopes toward the fading speck of light that is 3i Atlas, they are participating in one of humanity's greatest adventures. They are searching for answers to questions that touch the very core of our existence, questions about whether we are alone and what it might mean to live in a universe populated by other intelligences. The gentle acceleration of 3IA Atlas becomes even more intriguing when we consider the precise nature of its trajectory through our solar system. Unlike the chaotic tumbling motion typical of natural asteroids and comets, this mysterious visitor maintained what appears to be a remarkably stable orientation during its journey. It moved with the kind of purposeful steadiness that speaks to either extraordinary coincidence or deliberate design. Astronomers tracking the object noted that its spin rate was unusually slow and regular, lacking the erratic wobbling that characterizes most space debris. Natural objects that have spent eons drifting through the harsh environment of interstellar space typically acquire complex rotation patterns from countless gravitational encounters and impacts. Yet 3i Atlas presented itself to our telescopes with an almost serene composure, rotating with the kind of measured precision that engineers might build into a carefully balanced spacecraft. This controlled motion takes on even greater significance when we consider the object's size and shape. Based on the way it reflected sunlight during its passage, researchers estimate that 3i Atlas measures somewhere between 100 and several hundred meters across. If it is indeed artificial, this would make it roughly comparable to some of our largest spacecraft, though orders of magnitude more sophisticated in its apparent ability to maintain stable flight over interstellar distances. The object's reflectivity patterns also raised eyebrows among the astronomical community. Rather than showing the irregular brightness variations typical of tumbling asteroids with rough, uneven surfaces, 3i Atlas displayed relatively smooth changes in luminosity. Some researchers have suggested this could indicate a surface that's been artificially smoothed or polished, though others argue it might simply reflect an unusual but natural composition. Perhaps most intriguingly, spectroscopic analysis of the light reflected from 3i Atlas revealed a composition that doesn't quite match any known category of natural solar system objects. The spectral signatures suggest a surface that's neither purely rocky like an asteroid nor icy like a typical comet. Instead, it presents a puzzling mixture that some have described as almost metallic in nature, though the data remains frustratingly inconclusive. This ambiguous composition has led some researchers to speculate about materials we might expect from advanced extraterrestrial technology. An interstellar probe would need to be constructed from substances capable of withstanding the harsh conditions of deep space for potentially millions of years. Such materials might well produce spectral signatures, unlike anything in our current catalog of natural solar system objects. The timing of 3I Atlas's discovery also carries subtle implications that haven't been lost on those studying it. The object was detected just as humanity has begun to take its first serious steps toward becoming an interstellar species ourselves. Our own Voyager probes have already entered interstellar space, and we're actively developing technologies that might one day carry human made objects to other star systems. Could it be mere coincidence that we're encountering potentially artificial interstellar visitors, just as we ourselves are preparing to send artificial objects into interstellar space? Some researchers have suggested this timing might not be accidental at all. Perhaps advanced civilizations monitor the electromagnetic signatures of developing worlds, waiting for signs that a species has achieved sufficient technological sophistication to recognize and appreciate interstellar artifacts. Our radio telescopes have been broadcasting humanity's presence to the cosmos for nearly a century now. Every television transmission, every radar pulse, every attempt to communicate with our own spacecraft adds to a growing bubble of electromagnetic radiation expanding outward from Earth at the speed of light. Any sufficiently advanced monitoring system within 100 light years of our solar system would by now be aware that something interesting is happening on the third planet from the Sun. Ski. This possibility transforms 3 Atlas from a passive object of study into something far more provocative, a potential response to humanity's own cosmic coming of age. Rather than a random encounter with interstellar debris, we might be witnessing the first deliberate attempt by another intelligence to make contact with our newly spacefaring civilization. The implications of such a scenario extend far beyond astronomy into the realms of sociology, philosophy, and even theology. If 3I Atlas represents a calculated attempt at contact, what does this tell us about the protocols and ethics of advanced civilizations? The object's subtle presentation suggests a remarkably sophisticated approach to first contact, one that avoids the potential trauma of obvious alien visitation while still providing unmistakable evidence for those scientifically equipped to recognize it. This interpretation casts our current scientific debates about 3I Atlas in an entirely new light. Rather than simply arguing about natural versus artificial explanations, we might be participating in humanity's first examination of deliberately planted evidence of extraterrestrial intelligence. The object could represent a kind of cosmic test designed to measure our scientific maturity and readiness for broader galactic contact. The gentle nature of its artificial signatures, if that's what they are, speaks to a profound wisdom about the psychology of first contact. An obviously artificial object arriving in our solar system might trigger panic, denial, or premature attempts at communication by insufficiently prepared human institutions. but a mystery that requires careful scientific analysis to unravel allows us to approach the possibility of alien contact at our own pace within our own scientific and cultural frameworks. Some researchers have begun to explore what they call the zoo hypothesis in relation to objects like 3I Atlas. This theory suggests that advanced civilizations might maintain a kind of protective observation of developing worlds, monitoring their progress while carefully avoiding direct interference that might disrupt natural cultural and technological evolution. Interstellar probes like 3I Atlas could represent the monitoring infrastructure of such a system. Under this interpretation, we might expect to encounter more objects like 3I Atlas as our detection capabilities improve. Each would present similar puzzles, similar gentle nudges toward recognizing that we are not alone, while avoiding the potentially destabilizing effects of unambiguous contact. It's a remarkably elegant solution to what philosophers call the contact paradox. How do you introduce a developing civilization to the reality of galactic intelligence without overwhelming or corrupting their natural development? The trajectory analysis of 3I Atlas supports this interpretation in subtle ways. The object's path through our solar system provided optimal viewing angles for studying not just our sun, but also the major planets and their moons. If it carried sensors designed to assess the habitability and technological development of our system, it couldn't have chosen a better route. The fact that its closest approach to Earth occurred during a period when our astronomical observation capabilities were at their peak might not be coincidental. Even the object's communication strategy, if we can call it that, shows remarkable sophistication. Rather than broadcasting obvious signals that might be intercepted by military or governmental agencies before reaching the scientific community, 3I Atlas speaks through the universal language of physics and astronomy. Its message is written in orbital mechanics and spectroscopy, ensuring that it will be interpreted first by scientists rather than politicians or generals. This approach demonstrates what might be called scientific diplomacy at its finest. By presenting evidence that can only be properly evaluated through careful observation and analysis, 3I Atlas ensures that any conclusions about its nature emerge through the peer-reviewed scientific process rather than through sensationalist media coverage or governmental secrecy. It's almost as if whoever created it understood the importance of allowing human scientific institutions to maintain their credibility and authority during this potentially transformative period. The psychological impact on the researchers studying 3IA Atlas has been profound. Many report a growing sense that they are participating in something far more significant than routine astronomical observation. The careful analysis of each data point takes on existential weight when the results might confirm that we are not alone in the universe. Every spectrum, every measurement of position and velocity, every calculation of trajectory becomes a potential key to unlocking one of the greatest mysteries in human history. Yet the object maintains its enigmatic silence, offering tantalizing hints without definitive answers. It accelerates without obvious cause, reflects light in puzzling ways, and follows a trajectory that maximizes scientific return while minimizing cultural disruption. Whether through cosmic coincidence or careful design, 3I's Atlas has managed to present itself as the perfect first contact scenario For a scientifically sophisticated but still somewhat provincial civilization like our own, the ongoing analysis continues to yield surprises. Recent studies of the object's thermal emissions suggest internal structures that don't quite match what we'd expect from a solid chunk of rock or ice. The way it radiates heat appears more consistent with a hollow or partially hollow structure, perhaps with internal cavities or chambers that serve unknown purposes. This thermal signature has become another piece of the puzzle, suggesting artificial origin. Meanwhile, radio astronomers have been quietly monitoring the Rizapke Atlas for any signs of electromagnetic emissions. While no obvious signals have been detected, some researchers have noted subtle anomalies in the background radio noise when their instruments are pointed toward the object. These anomalies are too faint and irregular to constitute clear evidence of artificial signals, but they add another layer of mystery to an already enigmatic visitor. The possibility that we might be looking at technology from another world has also prompted serious discussions about what our response should be if the artificial hypothesis is confirmed. Should we attempt to send our own probes to intercept and study the object more closely? Should we try to communicate with it directly? Or should we simply observe and learn, respecting what might be a carefully designed protocol for first contact? These questions have no easy answers, and they highlight how unprepared we remain for scenarios that once existed only in the realm of science fiction. The subtle approach taken by 3's Atlas, if it is indeed artificial, suggests that whoever created it understands the delicate nature of interstellar contact and has chosen a path that minimizes potential disruption while maximizing scientific learning opportunities. As 3I Atlas continues its journey away from our sun, growing fainter with each passing day, it carries with it the potential to transform our understanding of our place in the cosmos. Whether natural phenomenon or artificial construct, it has already succeeded in expanding our conception of what might be possible in the universe. It has reminded us that we are still explorers in a cosmos full of wonders, still students in a universe that continues to surprise and challenge our assumptions. The gentle whisper of its passage through our solar system may yet prove to be the first word in a conversation that spans the stars, a conversation that began not with dramatic announcements or obvious displays of power, but with the kind of subtle scientific puzzle that invites careful study and thoughtful consideration. In its quiet way, 3I Atlas may be teaching us that the universe is far stranger, far more populated, and far more wonderful than we ever dared imagine. As 3I Atlas fades into the cosmic distance, becoming nothing more than a faint point of light against the star-filled backdrop of space, the questions it has raised continue to echo through observatories and research institutions around the world. Each night, astronomers point their instruments toward its retreating form, knowing that every observation might be among the last we'll ever make of this enigmatic visitor. There's something almost melancholy about watching it disappear, this mysterious traveler that may have carried with it the first tangible evidence that we are not alone. The scientific community has begun to grapple with what researchers are calling the 3I Atlas paradox, the uncomfortable reality that our most sophisticated instruments and theories may be inadequate to definitively classify this object. We find ourselves in the peculiar position of having detected something that appears to transcend our current categories of understanding. It's neither clearly natural nor obviously artificial, but something that exists in the liminal space between these classifications, challenging the very foundations of how we organize cosmic phenomena. This ambiguity has profound implications for how we might recognize future interstellar visitors. If 3I Atlas represents the standard for how advanced civilizations conduct their explorations, we may need to fundamentally revise our expectations about what alien technology would look like. Rather than the gleaming metallic craft of science fiction, we might expect to encounter objects that are deliberately ambiguous, designed to blend seamlessly with the natural debris of space while carrying out their mysterious missions. The object's apparent mastery of subtle propulsion has also opened new avenues of research into theoretical physics. If its acceleration cannot be explained by conventional outgassing or gravitational effects, then perhaps we are witnessing technologies based on principles we have yet to discover. Some theoretical physicists have begun exploring whether 3I Atlas might be utilizing exotic forms of matter or energy that exist at the very edges of our current understanding. Dr. Elena Vasquez, a propulsion systems engineer at the European Space Agency, has been studying the acceleration patterns of 3IA Atlas with particular interest. Her analysis suggests that whatever is driving the object operates with remarkable efficiency, producing thrust with minimal energy expenditure. If we could understand and replicate this propulsion method, she notes in her preliminary findings, it would revolutionize interstellar travel for our own civilization. The possibility that we might be reverse engineering alien technology from telescopic observations alone represents a fascinating convergence of xenoarchaeology and practical engineering. Researchers are now examining whether the subtle clues provided by 3I Atlas might offer insights into advanced propulsion concepts that could accelerate our own development as a spacefaring species. Meanwhile, the search for similar objects has intensified dramatically. Astronomical surveys that once focused primarily on near Earth asteroids and conventional comets are now being reconfigured to detect the subtle signatures that might indicate artificial interstellar visitors. New algorithms are being developed to identify the kind of gentle, unexplained accelerations that characterize both Oumuamua and 3SO Atlas. It's as if the astronomical community has collectively decided to take seriously the possibility that our solar system regularly receives visitors from other star systems. This expanded search has already begun to yield intriguing results. Several candidate objects have been identified that exhibit anomalous properties similar to those of 3I Atlas, though none quite as dramatic or well documented. These potential discoveries suggest that interstellar visitors might be far more common than we previously imagined, hidden among the vast population of small bodies that populate our solar system's as outer reaches. The implications for astrobiology are particularly fascinating. If interstellar probes are indeed common, it suggests that spacefaring civilizations might be relatively abundant in our galaxy. The galaxy could be crisscrossed with exploration missions launched by dozens or even hundreds of different civilizations, each following their own protocols for studying and possibly contacting other worlds. This scenario presents what researchers have begun calling the probe swarm hypothesis, the idea that advanced civilizations might maintain vast fleets of exploration vehicles, constantly mapping and monitoring the galaxy for signs of life and intelligence. Under this model, objects like 3I Atlas would represent just the visible tip of an enormous iceberg of interstellar activity, most of which remains undetected by our current observation capabilities. The psychological impact of this possibility extends far beyond the scientific community. Religious leaders, philosophers, and social scientists have begun grappling with what it might mean for human society to learn that we exist within a galaxy actively being explored and possibly monitored by other intelligences. Some find the prospect comforting, suggesting that we might not be as isolated or vulnerable as we sometimes feel. Others find it deeply unsettling, raising questions about privacy, autonomy, and our place in what might be a vast cosmic hierarchy. Educational institutions have begun incorporating the 3I Atlas mystery into their curricula, using it as a case study in how science approaches extraordinary claims and ambiguous evidence. Students are challenged to evaluate the various hypotheses, weigh the available evidence, and consider what additional observations might help resolve the mystery. It's become a perfect teaching tool for demonstrating the scientific method in action when confronted with genuinely puzzling phenomena. The object has also inspired a new generation of young scientists to pursue careers in astronomy and astrobiology. Applications to graduate programs in these fields have surged, with many prospective students citing 3I Atlas as their inspiration for wanting to search for signs of extraterrestrial intelligence. Universities are scrambling to expand their programs to accommodate this sudden influx of interest in what was once considered a fringe area of research. International cooperation in space science has also been strengthened by the 3I Atlas mystery. The object's brief passage through our solar system required rapid coordination between observatories around the world to maximize observation opportunities. This collaborative effort has demonstrated the value of global scientific cooperation and has led to new protocols for responding to future interstellar visitors. Space agencies from different nations are now developing joint mission concepts for intercepting and studying such objects more directly. The technological challenges of mounting an intercept mission to a fast moving interstellar object have pushed spacecraft designers to consider radical new approaches to propulsion and navigation. Solar sails, ion drives, and even theoretical fusion rockets are being evaluated for their potential to catch up with objects like 3I Atlas. These studies are advancing our own capabilities for interstellar exploration, ironically using potentially alien technology as the motivation for developing our own. As we continue to analyze the data collected during 3IXO Atlas's passage, new details continue to emerge that add layers to the mystery. High-resolution images captured during its closest approach reveal surface features that don't quite match what we'd expect from natural space debris. The surface appears remarkably smooth and uniform, lacking the craters and fractures typical of objects that have spent eons drifting through interstellar space. Spectroscopic analysis has also revealed trace elements in the reflected light that suggest a composition unlike any known natural materials. These exotic signatures could indicate either unknown geological processes or perhaps artificial materials designed for specific purposes. The debate continues as researchers work to determine whether these anomalies represent genuinely alien chemistry or simply exotic natural phenomena we haven't encountered before. The mystery of 3I Atlas has also prompted serious discussions about humanity's readiness for contact with extraterrestrial intelligence. If this object does represent technology from another civilization, our response to its discovery will set precedents for how we handle future encounters. The scientific community's measured, methodical approach has been praised as a model for how such discoveries should be evaluated and communicated to the public. However, some critics argue that we may be too cautious, too willing to consider mundane explanations when extraordinary evidence demands extraordinary consideration. They suggest that our reluctance to embrace the artificial hypothesis may be rooted more in cultural and psychological resistance than in scientific rigor. This tension between caution and openness continues to shape the ongoing investigation. The economic implications of confirmed extraterrestrial contact are also beginning to be studied seriously. If 3I Atlas represents our first encounter with alien technology, it could trigger revolutionary advances in physics, engineering, and materials science. The potential benefits to human civilization could be immense, but so too could the disruptions to existing industries and power structures. Investment in space technology and related research has already increased significantly in response to the 3 Atlas discovery. Private companies and government agencies alike are pouring resources into projects designed to better detect, study, and potentially interact with interstellar objects. This investment boom is creating new opportunities for innovation and discovery that extend far beyond the specific mystery of 3 Atlas itself. As our mysterious visitor continues its journey into the outer reaches of our solar system, it carries with it the hopes and questions of an entire civilization suddenly confronted with the possibility that we are not alone. Whether 3I Atlas ultimately proves to be natural or artificial, it has already transformed our approach to studying the cosmos and our place within it. The gentle acceleration that first caught our attention continues even now, pushing 3 Atlas ever further from the warmth of our sun and back into the cold darkness of interstellar space. With each passing day, it becomes more difficult to observe, more challenging to study, more likely to slip away with its secrets intact. Yet the impact of its brief visit will resonate through human consciousness for generations to come. In observatories around the world, astronomers continue their vigil, tracking the fading speck of light that might represent humanity's first glimpse of technology from another world. They know that every observation could be the last, every measurement precious beyond calculation. The data they collect now will be analyzed and reanalyzed for decades, searched for clues that might finally resolve the mystery of what we've been witnessing. And in the quiet hours before dawn, when the sky is darkest and the stars shine brightest, those same astronomers sometimes pause in their work to contemplate the profound implications of what they might be studying. They are reminded that we live in a universe far stranger and more wonderful than our ancestors ever imagined, a cosmos where mystery visitors from distant stars might carry with them the keys to understanding our place in the grand tapestry of existence. The data streams continue to flow from our telescopes, each measurement adding another piece to a puzzle that grows more complex with every observation. As 3I Atlas retreats beyond Jupiter's orbit, the signals it reflects back to Earth grow ever fainter, like whispers from a conversation we're straining to overhear. The astronomers who first spotted its unusual behavior now find themselves custodians of what may be humanity's most important discovery, guardians of evidence that could rewrite our understanding of life itself. Dr. Sarah Chen, working late shifts at the Mauna Kea Observatory, has become one of the world's leading experts on 3I Atlas's trajectory patterns. Her calculations suggest something that keeps her awake long after her observation sessions end. The object's path through our solar system wasn't random at all. It followed what she describes as an optimal survey route, one that would maximize data collection opportunities for any hypothetical instruments aboard the craft. The timing of its approach to each planet appears carefully choreographed. It passed Mars during a period when dust storms had cleared, providing unobstructed views of the surface. Its closest approach to Earth coincided with minimal atmospheric interference, perfect conditions for detailed observation. Most intriguingly, it lingered in the Jupiter system just long enough to conduct what would have been a comprehensive study of the gas giant's moons, particularly those believed to harbor subsurface oceans. This precision in timing and positioning has profound implications. Natural objects tumbling through space don't optimize their trajectories for scientific observation. They follow the blind mathematics of gravitational attraction and orbital mechanics. But 3I Atlas moved with what can only be described as purpose, as if someone or something had planned its route with the care of a mission specialist designing a grand tour of our solar system. The European Space Agency has quietly begun preliminary studies for an ambitious chase mission, though the technical challenges are staggering. To intercept 3 ISO Atlas now would require a spacecraft capable of reaching unprecedented velocities, pushed to the very limits of our current propulsion technology. The mission would be a one-way journey into the outer darkness, with no possibility of return. Yet the potential scientific rewards are so extraordinary that serious consideration continues behind closed doors. Meanwhile, the search for similar objects has expanded into a global effort coordinated through the International Astronomical Union. The new Interstellar Object Detection Network links telescopes across 6 continents, all scanning the skies for the subtle signatures that might indicate artificial visitors. The network's first major success came just months after 3I Atlas's discovery, when observatories in Chile detected another anomalous object exhibiting similar, unexplained acceleration patterns. This second object, is designated 4I Hermes, has added weight to the hypothesis that we may be witnessing a systematic exploration of our solar system. Like 3I Atlas, it shows no signs of conventional comet activity despite its non-gravitational acceleration. Like its predecessor, it maintains an unusually stable orientation and follows a trajectory that seems almost deliberately planned for maximum scientific return. The discovery of 4I Hermes has transformed speculation into pattern recognition. 2 such objects might be coincidence. 2 identical anomalies suggest purpose. The astronomical community now faces the uncomfortable possibility that our solar system is being surveyed by multiple artificial probes, each following its own carefully planned mission profile. The implications ripple outward through every aspect of human knowledge and culture. Philosophers debate whether the apparent observation of our world by alien intelligence represents a fundamental violation of our privacy, or simply the natural curiosity of advanced beings encountering a younger civilization. Theologians grapple with incorporating the reality of extraterrestrial intelligence into frameworks of meaning that have guided humanity for millennia. Perhaps most fascinating are the questions raised about the nature of intelligence itself. The sophisticated approach demonstrated by objects like 3-eye Atlas suggests minds capable of extraordinary patience and subtle reasoning. These aren't the conquest minded aliens of popular fiction, but explorers who seem to understand the delicate psychology of first contact. They approach with whispers rather than shouts, with puzzles rather than pronouncements. The gentle nature of their revelation has allowed human society to adapt gradually to possibilities that might otherwise have been overwhelming. Rather than triggering panic or denial, the mystery of Three Ios Atlas has inspired wonder and scientific curiosity. It's as if whoever designed these probes understood that the best way to introduce a developing civilization to cosmic reality is through the language of science, allowing discovery to proceed at a pace that preserves social stability. Dr. Martinez, now leading an international working group on interstellar object analysis, has begun developing protocols for what she calls graduated disclosure. Her team recognizes that each new piece of evidence supporting the artificial hypothesis brings us closer to a threshold where the reality of extraterrestrial intelligence becomes undeniable. They're working to ensure that when that threshold is crossed, humanity will be as prepared as possible for the psychological and cultural implications. The protocols include guidelines for media communication, recommendations for educational curricula, and frameworks for international cooperation in responding to confirmed alien contact. It's painstaking work that requires balancing scientific honesty with social responsibility, ensuring that transformative discoveries are communicated in ways that inform rather than destabilize. Meanwhile, the data analysis continues around the clock. Every spectrum captured from 3-eye Atlas is being examined with unprecedented detail, searched for chemical signatures that might reveal its true nature. Advanced computer modeling attempts to reconstruct the object's possible internal structure based on its thermal emissions and rotational characteristics. Machine learning algorithms comb through the observational data, looking for patterns too subtle for human recognition. The results paint an increasingly detailed picture of something that defies easy categorization. The object appears to have a complex internal structure with what might be hollow chambers or compartments. Its surface shows signs of artificial modification, smooth and uniform in ways that natural space debris rarely achieves. Most tellingly, its composition includes materials that don't match any known natural processes, exotic alloys that suggest advanced metallurgy. Yet for all these anomalies, 3-Eyes Atlas maintains its enigmatic silence. If it carries instruments designed to study our solar system, they operate with such subtlety that we cannot detect their function. If it's capable of communication, it has chosen not to reveal that capability to us. It continues its journey with the patient dignity of a scholar, observing without interfering, learning without announcing its presence. This restraint speaks to a wisdom that transcends our current understanding of interstellar diplomacy. The object's creators, if they exist, seem to understand that premature contact could be more harmful than beneficial for a civilization still struggling with its own internal conflicts and limitations. They offer evidence of their existence without forcing confrontation, allowing us to reach our own conclusions at our own pace. The psychological impact on the research teams has been profound and unexpected. Many report a growing sense of connection to something vast and ancient, a feeling that they are participating in a conversation that spans the cosmos. The careful analysis of each data point takes on almost ritualistic significance, as if they are translating messages from minds separated by unimaginable distances and timescales. Some researchers describe experiencing what they call cosmic perspective, a fundamental shift in how they understand humanity's place in the universe. The possibility that we are being observed and studied by advanced intelligence has made them acutely aware of our species' youth and inexperience on the cosmic stage. Yet rather than feeling diminished, many report feeling honored to live during what may be humanity's first contact with extraterrestrial civilization. The religious and spiritual communities have responded with remarkable diversity to the implications of 3I Atlas. Some see in its gentle approach evidence of benevolent cosmic intelligence, perhaps even divine guidance expressed through advanced technology. Others interpret its mysterious nature as a test of human wisdom and maturity, challenging us to grow beyond our planetary limitations. Indigenous cultures, with their long traditions of viewing humanity as part of a larger cosmic community, have often been more accepting of the possibility that we share the universe with other intelligent beings. Their perspectives are increasingly sought out as humanity grapples with expanding its conception of family and kinship to potentially include minds from distant stars. The economic implications continue to unfold as well. Investment in space technology has surged as governments and private companies recognize the potential benefits of understanding and perhaps eventually replicating the technologies demonstrated by objects like 3I Atlas. New research initiatives are being funded at unprecedented levels, from advanced propulsion concepts to exotic materials research. Universities are struggling to keep pace with student interest in astrobiology and related fields. What was once a small, specialized area of study has become one of the most popular and well-funded research directions in modern science. A new generation of scientists is being trained specifically to search for and study signs of extraterrestrial intelligence, preparing for a future where such discoveries may become routine. The international cooperation sparked by 3I Atlas has also led to broader discussions about humanity's collective response to cosmic citizenship. If we are indeed being observed by advanced civilizations, what kind of impression are we making? The question has prompted serious consideration of how our actions might appear to hypothetical alien observers, adding a new dimension to discussions of environmental protection, conflict resolution, and social justice. As 3I Atlas continues its journey into the outer solar system, now little more than a faint point of light, even to our most powerful telescopes, it carries with it the hopes and questions of an entire species suddenly confronted with evidence that we may not be alone. The gentle acceleration that first caught our attention continues to push it ever further from the warmth of our sun back toward the cold darkness of interstellar space from which it emerged. In the coming years, as our observation capabilities improve and our understanding deepens, we may finally solve the mystery of what Thrice Ios Atlas truly represents. Whether it proves to be an exotic natural phenomenon or humanity's first confirmed encounter with alien technology, it has already transformed our relationship with the cosmos and our understanding of our place within it. The quiet revolution sparked by this mysterious visitor continues to unfold in laboratories and observatories around the world, in philosophical discussions and spiritual contemplations, in the dreams and aspirations of young people who now see the universe as a place of infinite possibility rather than empty isolation. Whatever Three Eye Atlas ultimately proves to be, it has already given us the greatest gift imaginable, the knowledge that the universe is far stranger, far more wonderful, and perhaps far less lonely than we ever dared hope. And in the vast darkness beyond Neptune's orbit, Three Eye Atlas continues its ancient journey, carrying with it secrets that may someday bridge the gap between worlds, between minds, between the profound solitude of planetary existence and the magnificent community of cosmic intelligence. Its gentle passage through our solar system may represent nothing more than the first whisper of a conversation that will define humanity's future among the stars. The profound silence of Thrice O Atlas as it retreats into the cosmic depths carries with it questions that may haunt humanity for generations. Yet perhaps this silence itself is the most eloquent statement of all, a reminder that the universe operates on scales of time and distance that dwarf our terrestrial concerns. If this mysterious visitor is indeed artificial, its creators understood something fundamental about the nature of contact between civilizations separated by vast gulfs of space and evolution. Consider the extraordinary patience required to send a probe on an interstellar journey that might last millions of years before reaching its destination. The minds behind such an endeavor would need to think in geological timescales, planning missions that span countless generations of their own species. This perspective alone suggests a level of cognitive sophistication that challenges our understanding of what intelligence might become when freed from the constraints of brief individual lifespans. The probe's apparent ability to maintain functionality across such immense periods of time speaks to engineering principles we can barely imagine. Every component would need to be designed not just for reliability, but for self-repair and adaptation to conditions that might change dramatically over the course of its journey. The materials science required to create structures capable of withstanding millions of years of cosmic radiation, micrometeorite impacts, and the extreme temperature variations of interstellar space represents achievements that make our most advanced technologies seem primitive by comparison. Yet for all its apparent sophistication, Three Isles Atlas has revealed itself to us through the most subtle of signatures. Its message, if it carries one, is written in the gentle language of orbital mechanics and unexplained accelerations rather than the dramatic proclamations we might expect from a technologically superior civilization. This restraint suggests a profound understanding of the psychological and cultural challenges inherent in first contact between species that evolved in complete isolation from one another. As our gentle journey through the mystery of three-state atlas draws to a close, we're left not with definitive answers, but with something far more precious: expanded wonder at the cosmos that surrounds us. Whether this enigmatic visitor proves to be an exotic natural phenomenon or our first whispered greeting from minds among the stars, it has already transformed how we see our place in the universe. The questions it carries into the darkness may someday bridge the vast loneliness between worlds, reminding us that in a cosmos full of mysteries, the greatest discoveries often come not as shouts, but as gentle whispers that invite us to listen more carefully to the infinite symphony playing all around us. Sleep well and dream of the possibilities that await among the stars.